Okay, let's do quiz 5. All right, so here we go. Um, it says a family drives 6 hours and 15 minutes to arrive at a vacation getaway located 625 kilometers from their home. Determine their average speed with units of miles per hour. So, even if you didn't know the formula for average speed, our problem is solved just by knowing units, miles per hour. So what we need to know is how to convert all this into miles per hour. If you remember, you can take distance equals velocity times time. And so if you travel at 60 miles an hour, and if you travel for 3 hours, right, you are going to go or travel a total distance of 180 miles. And so most people are happy with that. And so we're not interested in the distance or the time. We're interested in the rate, miles per hour. So that's what we need, a length divided by a time. And so the length they gave us is 625 kilometers. 625 kilometers. And the time they gave us is 6 hours and 15 minutes. So 15 minutes is 1/4 of an hour. So then this is going to be 6.25 hours. So we want miles per hour. We've already got kilometers per hour, so we just have to add a conversion. And so you might think, well, I don't know the conversion. Well, wait a minute. Didn't we just learn that there were 1609 meters is equal to 1 mile? And you knew that. But we can bring that decimal point over 3 places, and we'll get 1.609 kilometers is 1 mile. Okay, so there's no excuses. What you need to do is you need to know those conversions, and you can do this. So we have in each 1.609 kilometers, we have 1 mile. And the kilometers will drop out, and we'll be left with units of miles per hour. So all we have to do is calculate it. So we're going to take 625, and we're going to divide that by 6.25, and we're going to divide that by 1.609, and we're going to get 62.1. We're going to get 62.1 miles per hour. And there we go. Good. A company wants to sell small, medium, and large pizza, and that has a diameter of 10, 12, and 14 inches. So if the company determines the small pizza should be $8.99, what should the other prices be for the medium and large? Well, the company wants to sell a pizza, and it costs so many dollars per area of the pizza. And so the formula for area is going to be pi r squared. And in this case, they gave us a diameter of 10 inches, so our radius is going to equal 5 inches. And so we know they gave us $8.99 for a small pizza. Well, the area of a small pizza is pi times our 5 inches, and then we need to square that. So what we're going to get is a new conversion factor. $8.99 per 5 times 5 is 25 pi inches square. So for this much area, it costs this much dollars. And don't worry, you can leave the answer in units of pi. You don't have to actually multiply that out, because in this case, the pi is actually going to cancel, and I'll show that to you now. Well, we want to find out what a medium pizza is going to cost. Well, a medium pizza has a diameter of 12 inches, that means the radius is 6. If the radius is 6, then the area is 6 times 6 is 36 pi inches square. And our conversion factor says for every 25 pi inches square, the cost is going to be $8.99. Notice the pi inches, well, the inches squared drops out, the pi drops out, and so we'll be left here with a quick answer. 36 divided by 25 and multiplied by 8.99, $12.95. So $12.95 is our answer. That's for the medium. So we can either have this top one or the bottom two. Okay, so now the large pizza is 14 inches. So the large pizza is 14 inches, and so the radius is 7, and it's half the diameter, and 7 times 7 is 49 pi. So now for the large pizza, we're going to have 49 pi inches square. And then we have 25 pi inches square, and it costs $8.99. So now we just multiply that out, and remember again that the pi inches squared is all going to drop out. So 49 divided by 25 and multiplied by $8.99, and we get $17.62. So the large pizza is $17.62. So medium is $12.95 and $17.62. I think it's this last one right there. $12.95 and $17.62. That looks good. A parent wishes to paint the walls of a bedroom, and they gave these dimensions. So if this is the bedroom, and one side is 14 feet, and I'll use the dash, like 6 feet 2 inches, 1 dash is feet, 2 dashes is inches. And so it's 14 feet, and we have 12 feet over here. So, and we only want to paint the walls. When we do not want to paint the ceiling. It just says the walls. So, and the walls are 8 feet tall. So 14 feet times 8 feet. So we're going to have 14 feet. And we have to multiply that by 8 feet. And that's going to give us this wall right here. But then there's another wall right here that's going to be the same. So we got to multiply that by 2. And then we have the other wall to do. And that's going to be 12 feet. And that's by 8 feet. Because it's the same height ceiling. And then again, of course, we're going to have 2 walls like that because you have one on the other side. So if we add those together, we have 14 times 8 times 2 plus 12 times 8 times 2, and we get 416. And it's going to have units of feet squared. Well, we want our answer to have units of meters square. So that gives us 416 feet squared. And we should know that in each foot there are 12 inches. And it's squared. The feet is squared, so we have to have feet squared here. So we could write the bracket again, or we can just square it. However you want to do it. I prefer to square it because I'm going to run out of room. but you can write it out however you want. You can put another 12 inches over 1 foot and another bracket. It's perfectly fine. However you want to do it. But we still have to get meters, and we're only at inches. So there's 2.54 centimeters in an inch. And now the inches have to go up here because we have to square that, or the inches have to be squared, so we have to square that up here. That's what I mean. And now we have to convert centimeters into meters, and there are 100 centimeters in 1 meter. And then we can square it. And so I think that's going to give us a good answer. So 416 times 12 times 12 times 2.54 times 2.54 and divided by 100 and divided by 100 again. And we get 38.6. 38.6 meters squared. Notice that this feet is going to be squared, so the feet will drop out. This inch is squared, and so is this one, so that will drop out. This centimeter is squared, and so is this one, so that centimeter will drop out. And I'll be left with meters squared as my answer. 38.6 meters square. Determine the surface area of 3 different size balls. Okay, well, what's the formula for surface area? Surface area of a sphere is 4 pi r squared. And so the surface area is going to be 4 pi r squared. So if the radius is 3 centimeters, that means 3 times 3 is 9, and 9 times 4 is 36. So I'm going to have 36 pi is going to be the surface area, 36 pi. And so and it's actually going to be 36 pi centimeters square. There's no unit here, so but the radius is squared, so definitely it's 36 pi centimeters squared. So the second one is 6 centimeters, and 6 centimeters squared, or excuse me, 6 centimeters squared is 36, and 36 times 4 is 144. So we have 144 pi centimeters square. And so that's good. And then now the next one is the radius is 9 centimeters. So 9 times 9 is 81. And we have to multiply that by 4. And we're going to get 324. 324 pi centimeters square. So 36 and 144 and 324. So this is our answer. Determine the volume of 3 different size balls. Okay, so we want the volume of these different size balls. So the volume then, the formula for the volume is 4/3 pi r cubed. So the volume then is easy to calculate. We have the first one is 3 centimeters. So we're going to have 3 centimeters, and then we're going to cube that. So that's 3 times 3 times 3. And we have to multiply that by 4 and divide it by 3. And we get 36 pi. This is a volume now. And so that radius was cubed. So we're going to have pi centimeters cubed. Again, I forgot the units on here, but I'll change that in the quiz. Pi centimeters cubed. Okay, let's see. We have the next one, 6 centimeters. So now we're going to have 6 times 6 times 6. Remember, it's 6 centimeters cubed. And then we're going to multiply that by 4 and divide that by 3 for the 4/3. And we're going to get 288 pi centimeters cubed. And then we have the third one, 9. 9 times 9 times 9 multiplied by 4 and divided by 3. And you get 972. 972 pi centimeters cubed. So 36, 288, 972. 36, 288, 972. And like I said, I'll change that in your quiz. I'll make sure that that I have the centimeters squared up here for area and centimeters cubed for volume. A number without units has essentially no meaning. You need to make sure that your numbers have units, and I didn't do that. So I'll change it. Copper is ductile. Ductile means you can take a metal and draw it into a very, very fine wire. It says determine the length of a 16 gauge wire. A 16 gauge wire has this radius that can be made from a 3-inch cube of copper. And it says express your answer in units of meters. Well, first of all, let's find out how much volume of copper we have. Remember, it says it's a 3-inch cube. So a cube has a certain length, and it has a certain width, which is the same as the length, and a certain height, which is the same as the length and width. Or we could have just said L cubed. And so one length, one side cubed is a cube. So in this case, we have 3 inches, and it's got to be cubed. So that's going to give us 27. 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. 27 inches cubed is that's the volume of copper that we have. Now we're going to take that copper and we're going to draw it into a fine wire. So the wire is going to have a certain length and a certain cross-sectional area. So this area right there is going to have, this is the area right there, the area of the wire. And so that area of the wire is the cross-sectional area, and this is the length. Well, what is the volume? What's the volume of this cylinder? I mean, that's what it is. A wire is a cylinder. So the volume of a cylinder is that cross-sectional area, pi r squared, multiplied by the length of the wire. Well, we know what that volume is. We just calculated it. It's 27 cubic inches. 27 cubic inches. And that's going to be pi. And what's our radius? Well, they told us 0.0254. 0.0254, and it's inches. That's good. And we have to square that, pi r squared L. So now we can get the length of this. And so we take 27 and we divide it through by pi. Let's just divide through by, let's take approximation of 3.14. And then we're going to divide that by 0.0254 and divide that by 0.0254. Now, you don't have to, I'm not sure what your math is like. So if you want to multiply this out and get some number times L is equal to 27 inches cubed, and then do the math, that's fine. However you get the right answer. So 13,328. 13,328. And now notice we're going to have inches squared on this side and inches cubed over here. So that means we're going to have units of inches. So let's just go ahead and do this. So we have 0.0254 multiplied by 0.0254, and we're just going to use 3.14 as our answer. And we're going to get something really small. We're going to get 0.00258, and then there's even other stuff after that. And then we'd have to so all that pi times the r squared, and then here's our L. Okay, so we have that number times L is equal to 27 inches cubed. So maybe that's easier for you to see. So I'll take 27 and divide that by 0.00200258, and I get 13,328. Get the same answer. But this is going to have units of inches squared. I forgot that. And then this side's got inches cubed. So if this has got inches cubed, the two of those are going to cross out with the inches squared. So that way you can easily see, yes, we should have units of inches for our answer. But we still haven't answered the question because we don't want it in inches. We want it in meters. So we have to 13, when is this problem going to end? 13,328. 13,328, and we have inches now, and we have to get to meters. And there's 2.54 centimeters in an inch. And that 2.54 centimeters has to go in the numerator so we can cross out the inches. And then there are, for every 100 centimeters, there's 1 meter. So 13,328 multiplied by 2.54, and now we have to divide through by 100. And I get 338 or 339, somewhere around 338 and a half is what it says. So 338, but we made some approximations, meters, and that's what answer is here, 338. Well, I hope that went well for you. Notice that some of these problems is just plugging it in, but some of these require several steps to get the answer. None of the steps individually are difficult, but some require much more effort to solve. But that's okay. Just do each section the way it should be done. I mean, it's not it's not to overburden you. It's to let you see that each small section is not difficult. Sometimes people look at the problems and they say, oh, those are too hard. No, they're not too hard. What it is do you understand all the principles of a bunch of easy things and shove them together? And so that's what this was supposed to demonstrate. Complex conversions are next. So we're going to take our knowledge here of brackets and we're going to expand on it a little further. So keep practicing.